Yeah, so I mentioned it before. I'm one of the BBF data modeling program stream co-leads together with Mathieu Anne, who is talking about data models in the next session. But other than that, yeah, still the same person. So I wanted to give you an overview of what we actually do in the Broadband Forum regarding the data models. So what resources are available. And then I wanted to talk a little bit about data model features. Again, some of them have been explained already or have been asked in the Q&A. I wanted to explain how to use a data model, where use is a little bit of abstract because there are many ways how you can actually use a data model and what you can do with it. And yeah, I guess I only have like half an hour time to, yeah, I can't do everything in this single talk, but I will try to break down a few of the key concepts. And then, of course, we have some takeaways for you before we go into Q&A. Yes, so some of that was already mentioned by Jason, but the important bits here are we do have what's called Tier 106, which is what we call a data modeling template. So that includes both the schemas and also a document explaining how to use it. I have a slide for that on the next page. Then we have our data models, the most important of which is Tier 181, which is the root data model. We have a number of service data models. So we have Tier 104, which is the voice data model. We have Tier 135, which is the set-top box data model. And then we have Tier 140, which is the storage data model. And then there's also a femto access point data model. So basically, we have this concept of divvying up certain things and yeah, having them outside of Tier 181 because as you've seen before, the document or the report of the document is already quite huge, and yeah, we are trying to keep things a little bit separate. Maybe we should do more of that, but that's a different discussion. We also have a set of tools that allow us, for instance, to create those nice reports that you have seen. So the tools can do a little bit more. They're also used in our continuous integration pipeline to basically verify and make sure that all the work that we are doing is actually useful and correct and there are no mistakes in it. So everything we can figure out automatically, we try to do automatically and immediately fail, for instance, builds. So we know that whatever we put in makes sense and is somewhat coherent. And there are two different versions of that tool. So I'm also going into that in a little bit. We have the old version, which is written in Perl, and we have a new version, which is written in Python, which we are trying to get to rather soon and try to get rid of the old ones. So in terms of the data model template, Tier 106, this basically provides the XML schemata and a number of shared resources. So we, for instance, reference a lot of other standards, so IETF standards, IEEE standards, and also various other websites, and those are all part of the biblio. So if we want to add an RFC, for instance, to a data model, we can basically simply refer to the RFC by number, and everything else is in the biblio. So you get a nice list of used references at the end of the documents, but that's all part of Tier 106, so we don't have to repeat ourselves in all of the different documents that are actually based on 106. There's a dedicated webpage for that. It's called Data Model Template at broadbandforum.org. So that's where you can actually get the document, the description, but also the schemas. And again, all of those are basically cross-linked. So from the USP page, for instance, you can get directly to this page and to all the other pages. The document itself is actually quite interesting, and few people know about that, but it explains basically all of the features that you can have in a data model, and it gives you a textual description of what they actually do. So especially if you're interested about the data types, how you would use the data model, what is allowed, what is not, what are our internal rules regarding updates to data models. So what is considered compatible and allowed to change, or what is considered, breaking changes. That's basically all described in Tier 106, the document. And yeah, again, it's a little bit unknown and underrated. But it's actually a very important document. And if you want to use the Broadband Forum Data Models, you're highly encouraged to actually have a look, because that might answer also a lot of your questions that you have. So the most important data model that we have is Tier 181. Again, maybe also not well known, but Tier 181 actually consists of two parts. So we have the document, and that's what I mentioned here. So the document provides information about the root data model. There's also a lot of theory of operation information in there. So as we mentioned before, when we introduced USP, we actually tried to get rid of all of those separate documents that refer to one specific protocol, like Tier 157. So that was assimilated into the Tier 69 specification itself, the USP specification, but also some of that moved into Tier 181 because it applies to both CWMP or Tier 69 and USP. So that's kind of important. This really provides a lot of information about concepts that we have in the data model, like, for instance, the interface stack concept, and we also have an explanation of how things like software modules work. It's not exhaustive, but it provides a lot of information. And whenever we add something that's rather complex to the data model, we always try to also update this document to explain how would you actually use this in real life. And again, this applies to both Tier 69 and USP. So this is a generic description of everything. And yes, you can find it under device data model, broadbandforum.org. We tried to get away from the PDFs, which were always tedious to generate. So nowadays we are trying to do as much as possible in Markdown. So the primary way of consuming this would actually be going to the website and looking at it in HTML form, which of course you can also download, but yeah, might be a little bit more tricky with all of the images and diagrams in there. Yes, so this also provides references to the adopted standards wherever possible, but that's the document. And then we have the data model itself. So that's what all people know and use and love, hopefully, which is the data model itself. So as we said before, this comes in two flavors. That doesn't only apply to Tier 181, but it applies to all of the data models. So we basically separated out what is CWMP specific, what is USP specific, and there's a large shared part. But we are basically condensing it down and generating two specific flavors that also contain information about how you would use it in a particular protocol. So if you look at the generated reports, if you look at the CWMP version, it refers to some CWMP only concepts. If you look at the USP version, it refers to some USP specific concepts wherever there are differences in the protocol. So despite being the same data model, the report also gives some protocol specific usage information about those. The data model itself is written in XML. So it's basically based on the Tier 106 schema that I already mentioned. And we are splitting it up into multiple files. And actually they're stored in a Broadband Forum specific Git repository. So members have access to that or can get access to that. And of course, we always invite contributors. So if there's anything you don't like about the data model, you can always, create an issue for that. And also, you're welcome to basically contribute a suggestion on how to implement something. So those XML files, they are not directly meant for consumption. So this is really a format that allows us to automatically process them. As I said, we have the ability to validate them and run various checks on them. And also we are automatically generating a lot of, let's say, boilerplate information that you can read in the data model. So we are directly creating that from attributes that we store in the XML files. And yeah, we try not to repeat ourselves because things that can be automatically generated are a simple tools change, whereas if you have something that's repeated in multiple times and you want to change it, then yeah, you have to change all the different instances. So that also helps to keep our sanity. So we do have the compiled versions. Since they are split up, we are basically reassembling them into a single document, and there are two different versions. So there's USP Data Models .broadbandforum.org, and there's CWMP Data Models .broadbandforum.org, which contain those. Again, find them through the other side. So easiest way to access all of that is usually USP.technology, rather than remembering the long host names with all the dashes in them. So that's usually much harder to remember. And yeah, so we recombine them into a single protocol-specific XML version. But of course, for human consumption, you typically refer to the generated report. So that was Jason was showing before. We should also add on his machine, it automatically picked up the dark mode, but we also have the bright mode that people might be more familiar with. But you can basically switch between them. I briefly mentioned we also have the service data models. So the service data models model specific services, and they're actually mounted under device.service. So we do have the concept of mount points in the data model, which basically means that some of the functionality, some of the components can actually be in different places of the data model, and device.service is one of those mount points where you can actually put stuff in, and in particular for the services we put into the service. So if you have something like tier 104 supported on your device, that would go under device.service.voice service, and then you can even have multiple instances of that. Same as for tier 181, the service data models and the rendered HTML output are on this very same pages. So if you want to have a look at those, also go to cwmp-datamodels.broadbandforum.org or the other one, or find them through something like USP.technology. I briefly mentioned we have our tools. So the old tool is a Perl script, and that can basically be used to process any tier 106 compliant XML files into various output formats. This is actually published on GitHub, so you can basically go to the Broadband Forum GitHub setup and find the report tool there. But we also provide a Docker Hub image or an image on Docker Hub, so you can actually directly use it rather than having to deal with having to install multiple Perl modules just in order to get it up and running, which can be a little bit annoying. So this provides some limited validation of the data models and is mainly used for transformation into other formats. So this can generate those reports, but there are also other ways that you can use that. For instance, you can provide profiles that you want to implement, and then it can filter out the things that are mentioned in the profiles and generate a full data model for you that only contains those profiles. There are also DT files. I don't think I want to talk too much about them, but the DT files are basically a specification of things that you want to include. So basically you can say, I want this, 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 and this. And this is a very easy way to actually generate a data model that is compliant. And then again, you can use the report tool to, for instance, generate a report of just the implemented data model. That's actually quite a nice feature. Jason mentioned it already. I'm probably the only real user of that, but I'm using that extensively. So that's what we use to basically model data models that go onto devices. And it's quite convenient because you have this automatic tool. You can generate things like source code from it, and you can also generate a report that you can give to your customers and say, you know, this is what we implement. And there's no discussion about it. There are no mistakes in it because what you see is what you get. It's basically all generated by the report tool. Then we have the new kit in town, which is the Python version of the report tool. So it's rewritten in Scratch. So one of the problems of the report tool of the Perl version is it is extensible. So you can do a lot of interesting stuff with it, like generate source code, as I mentioned. The problem with that is, yeah, how many people in the room know about Perl? Okay, so 3 persons out of, I don't know, 30. And the question is whether you could actually write a Perl module for that. So it's not a lot of fun, I can tell you that, and it causes a lot of headaches. So that's one of the reasons why we created a new, much more modern Python version that people can use. It has a number of big advantages, including of being more modern and having more modules at the fingertips that we can actually use to do stuff. So this, for instance, is used to also really do schema validation now. And it has a lot more checks implemented. And it eventually is going to replace the old report tool as soon as all of the functionality is available there. So that is actually published to PyPy. So there's a package called BBF report. So basically, if you're a Python user, you can do pip install BBF report, and it will automatically give you the report tool, and you can use it right away. So most of the things that we do nowadays and all of the published stuff is actually now rendered with this particular new tool. And yeah, it's a lot stricter than the old report tool. So we are also still figuring out some misuses that we had over time, and that are still part of the current data models. So it's getting stricter all the time and finding more stuff. And some people hate it, other people love it. But yeah, so David in the back, for instance, he's a big fan of the report tool because he gets so much errors. And then basically, since he is now doing most of the data modeling work, he has to recreate all his pull requests and update them to accommodate for the problems that are reported. So that's kind of nice. I don't know how much more time do we have, Jason? I have 10 minutes. Oh, that's not a lot of time. Okay. So what are the things that are actually in the data model? Again, most of this is repetitive. So we have from previous talks. So we have objects which can be either single or multi-instance, and the later is indicated by the curly braces I. We do have parameters, and then we have the USP-specific elements, which are events and commands. And basically, those are formed into a hierarchy, and that hierarchy is basically what makes the whole data model. So this is a familiar look if you look at the report tool. So I put in the versions from the Bright data model report rendering. So it's probably hard to read, but if you look at the data model report yourself, you can immediately identify what's what, because we have individual color coding for all of those elements. So this would be an object, and you can see it has some information in the data model report. So that includes the full name of the object. In this particular case, it's device info processor. You have restrictions or type information. about that particular object. So here, for instance, there would be a multi-instance objects, and there are no limits on how many instances can be there of this particular object. So we also have like singleton objects, or I think we don't have too many, but there might be also objects that have some other limitations. And that's actually something that you can do with those DT files, that you can put a limit on it. Like you can say, my specific implementation of this data model, there will not ever be more than 10 objects of this kind. Yeah, like firmware images, you can basically restrict how many objects are allowed in a particular implementation. Then you have the constraints. So objects can be creatable, they can be deletable, and they can be like read-only, like they're created by the device or by the implementation. And you get what you get. Then you have a textual description, and then you have a column that's actually ignored for objects. And the last column is the data model version in which the element first appeared. So that usually gives you some indication on, how old something is or how mature something is. Of course, if you look at the latest version of the data model, you will find also the stuff that is actually new in a particular version of the data model, which is also kind of interesting, because then you can easily see the differences between the versions. Then we have the parameters. So the parameters is where the most of the data actually goes. So that parameter rendering basically gives you the parameter name. Of course, this is only the partial name. We don't want to spell out the path all the time. So this is basically a parameter is always underneath an object. And that means that, of course, you have to prepend the parameter name, the object name to the parameter if you want to use those in an implementation, if you want to refer to them. And yeah, you have some parameter type and type restrictions. So there are a variety of restrictions that we are already placing on those parameters. For instance, we know some data is going to be binary data, so it might be a hex binary type. We have integers, we have other types, and those types have also implicit restrictions, like maximum, the maximum it could take, or the minimum it could take. We have lists in there, so there's lots of different types that we can use, and they basically already typically restrict the use of a parameter value to some certain elements. Then we can have read and write constraints. So that would basically mean, something that is provided by the implementation itself, or something that can actually be written by, TR69 ACS or USP controller. Then we have a description of the meaning. So usually you can see, the blue stuff is links. So they typically refer to like the biblio, or they refer to other parameters that control their use or define their meaning. Then there can be a default value. So in this particular case, there's no default, but or there's an implicit default. So that also exists for string. The default is usually an empty string, right? And of course, you have the data model version in which the element first appeared. Then we do have the events, which are USP only. So you can see those are green. They basically have just the event that's described, and you have a description of what the event actually represents. And then if you go to the next columns, you can actually see the output argument. So that's the information that can be provided with a particular event. And yeah, we have some additional information about that. So not only what kind of type it is and what it means. So we have this representation. Again, we have the version, and those can also be mandatory. So they have to be implemented, or they have to be provided whenever you receive the event. And then we have the commands, which again are USP only. So those are a little bit more difficult, because commands can be, as we said before, synchronous or asynchronous. They can also have a variety of different input arguments, but they can also have some output arguments. So that's information that you get when they basically complete and you have properly subscribed to receiving the result, then that's what you would get, right? So in this particular case, I have an example for schedule timer. So schedule timer basically just generates a event at a certain point in time. So again, you have your input arguments, and those input arguments would, in this particular case, be delay seconds. So delay seconds, of course, cannot be 0. So you have to wait at least 1 second, and that's a mandatory input argument. So you have to provide it. And that would basically mean if you call the schedule timer with an input argument of, delay seconds 5, and you have the proper subscription for that, then in 5 seconds, you will basically receive an event that says, by the way, your timer just ran up. Yeah, indeed. So if you look at the data model, what's kind of interesting, we have the ability to provide an easy access. So on the left-hand side, you basically have the table of contents of the whole data model. So this only contains the objects, and you can see there are some plus and minus signs there, which allow you to basically open up a branch or remove a branch. But those will contain all of the objects that are directly accessible in the particular data model. And you can just click on it, and it will directly bring you to wherever you want to go. We also have the ability to add links automatically. So whenever we refer to something else in the data model, you can see those blue links in the bright version that allow you to basically jump between those elements. There's also some hover over information. So some items you can actually hover over, and they will give you additional information on what that actually means. Like for data types, for instance, we sometimes provide some additional information if you hover over it. And also there's this hover function for all of the elements. So you can see when you hover over a parameter name, object name, whatever, it will show this little chain symbol, and this particular chain symbol will allow you to basically directly jump to that page. So you can give the link that is behind that symbol to a colleague and say, this is what I found in the data model. Is that something that we want to implement? So it's rather easy to basically also generate links that you can hand over to other people to get quicker to the information. Okay, so what do you want to do with the data model, right? So it's actually a design process that you need to do in case you are considering of actually not just using a data model, but actually providing a data model, for instance, in a device implementation. So there are various things that need to be considered if you want to implement such a data model. So for instance, you have your typical protocol-specific configuration elements, so TR69 or USP-specific elements that need to be included. You of course want to include all of the available internet technologies that your device can support, so different WAN technologies, DSL, fiber, 5G, what have you. You of course want to provide at least the minimum configuration that is required to actually obtain internet access, because otherwise the device wouldn't be too useful. Then of course you have your hardware features that you need to support, like Wi-Fi is very common nowadays, video maybe, smart home, telephony, what have you. Then of course you need to provide the configuration for the software services that you have. So those could be things like services that are accessible, like DHCP server, or web interface, but this could also be something like the containerization that we talked about, where you actually want to create your containers and manage them. So lots of different possibilities here, and that's usually the majority, I would say, of the services. So or the last 2 points are the majority of what you will find in the data model. And usually that is, of course, driven either by your own needs or the things that you want to offer to your customers if you're a device vendor. But also very often this is driven by the operator saying, you know, we need this kind of information because we want to improve our customer support or whatever. So that's what we need to put in. Yeah, in order to define a data model, you basically need to somehow drill down on the data model. Of course, it doesn't make sense to say, here's tier 181, implement it, right? So a lot of the things that are in the data model don't really make sense for a particular implementation. So if you don't have a cable device, then what do you want with a MoCA implementation? Or so you actually need to drill down a little bit. So things that you can do here is basically you can create a DT, and the DT will allow you to specify, this is what I want to have. You can also define it all by hand if you need to, but that's highly not recommended. You can also use the profiles, as I said before. You can basically use the tools to say, give me, you know, I don't know, PPPoE dot, :1 profile, and then it will give you automatically all of the objects and parameters that are supposed to be implemented there. So that's much more comfortable to actually drilling down. But yeah, you need to figure out what you need to include, and there are also some cues in the data model, in the description itself, like things that are keys, which would have to be implemented by the data model in order to make something actually usable. Yeah, so the key takeaways here are the Broadband Forum does a lot of groundworks by defining the schemas and also providing the tooling. So it's not just, you know, something that can only be consumed in HTML format, but you're very much invited to actually use the tools and the raw inputs that we generate yourself. We have a lot of members actually that are continuously contributing to the data model. So again, I mentioned it before, if you find anything missing or you see room for improvements or errors, please report them to us. And if you are a member, you're more than welcome to actually, you know, say, this is what I want to have, and then we will work with you to get it into the data model. They're very extensive, so there are lots of things that you can actually pick from the data model, and with each new version, there is a lot more additions, which we now also document in terms of changes. And yeah, you can find probably most of the stuff that you need in your daily operation inside the data model already. If not, then yeah, please come back to us. And yeah, by relying on the published data model, so that's kind of an important point, because especially in the tier 98 world, every vendor had like, you know, 90% vendor specific extensions. So that makes for a really horrible interface if you actually want to use devices from different vendors. So by having this and by making it useful and by continuously improving on it, we basically can harmonize on a single set of configuration that is implemented by a lot of different vendors. So that gives you a really good compatibility, and that makes it easier to use, and also to understand how to actually configure and monitor a device by having this harmonized set of information.
I didn't wear my "Don't Use Vendor Extensions" t-shirt. I should have brought it with me. I didn't do it. Great. Thank you, Daniel. I realize this material has been, I think, a long time coming, because obviously the data models have been existing for a long time, but I don't think we've ever done a very good job of sort of conveying to everybody exactly how it is that you're supposed to consume them and why. Does anyone have any immediate questions before Matthew jumps in? He's going to follow up with a lot of what we're talking about right now and talk about how to contribute and also what's new in device 2.17.
Do you have a mapping table or maybe even a tool to map from older versions to like a TR69 to USP or data objects and things like that? Or is it just you have to know it?
No, well, basically, you mean for commands and RPCs? No, we don't. But
not for commands, for the data objects.
Yeah, the data model itself is pretty much the same, except for the, let's say, 5% of protocol-specific stuff.
Okay.
So there's no need to map between TR69 and USP. It's really the same.
Oh, good to know.
And Daniel, I don't remember if you mentioned this, but if we showed the website, there is actually different versions of the report that are published. So there's one that is everything, and then there's one that only shows you the diffs between the last version and the current version. So that's always extremely helpful.
Yes, yes. And now we also do release notes. So we will basically try to break down what has changed and give a brief description.
One thing that I wanted to mention of sort of like there's a lot of what Daniel presented that is stuff that basically we use at the Broadband Forum because we have to publish the data models. And you often think sort of, why would I ever go through this process myself? In addition to what Daniel was talking about device type and making a data model that's specific to something that you've implemented, it's also good for building requirements, right? So saying
absolutely
what you want a device to look like that you want someone else to build. And I think a really good example of that right now, because you can include vendor extensions and stuff like that when you build your own data model, making sure that you use the right mechanism for defining a vendor extension so things don't get confusing. A really good example that has happened recently is with Purple, right? So they obviously aren't implementing all of TR181, obviously, but they want to tell people what it is that they should implement if you're going to be implementing Purple OS in some capacity. And so they went through this process, right? So they define their own profiles. They reference you can basically import things from TR181 that you're just going to reuse verbatim. So basically their XML documents look like a series of imports of TR181 objects, the ones that they want to use. Then they define their vendor extensions, and then they define their own profiles.
Right. So that's one thing I forgot to mention. You can actually define your own profiles that references things as well, rather than generating a DT. Yeah, good point.
So if one decides to, let's say, go for a newer data model in the new firmware release, is there any specific mechanism for updating the controller or ACS to let it know that, for example, we get rid of some vendor-specific parameters because the new data models the functionalities that we used to have under vendor-specific elements?
No, so we don't deal with vendor specifics. So that would be, implementation dependent. So
yeah, I'm not asking specifically about those vendor-specific, but is there any mechanism to update the controller to let it know that there is a new data model and that it has to, for example, update the supported data model, right? So to call the specific command.
Yeah, so those are basically independent concepts, but indeed, by using actually the XML files or referring to the XML files, you can simplify your upgrade process by simply say, oh, instead of version 2.16, I'm now using version 2.17, and whatever has changed in the data model will automatically be picked up by the implementation. And the second thing is, you can use that, and every controller can subscribe to their own set. So the notifications that you get, the subscriptions, are always controller specific. That's what we mentioned before. So if you have multiple controllers, then each of them has their own set of notifications, and there are also access controls and permissions in the data model that will restrict or might restrict on which access or which parameters or which data one controller can access. But yeah, each controller can create their own subscriptions for the boot event and include their own set of parameters they would like to see.
But what I meant is that, assuming that the controller have not subscribed to the boot event, can the controller still get this information via
no?
GET? No. Okay.
Well, you can always get the information via GET, right? So
okay, even though it's on under event, not under.
no. Everything you can put into the boot event, the boot parameters, they are actually part of the data model. So whatever the device implements, you can receive. And of course, you can also get the information using a GET. Yes.
Okay, thanks.
And yeah, so to hammer home Daniel's point, the boot parameters that are included in the boot notification are controller specific, and they're under the controller object. So you as a controller, you're like, oh, this is where I configure my things. The boot parameters that you want will be specific to you. And you say,